All right. Ladies and gentlemen, let's get started. Okay. So today we are extending our calculus and derivatives and higher order derivatives to physics. So you will see that physics and calculus tie in together. Gentlemen, I know last year or whenever you took physics, your physics was algebra based. When you get to college and you take physics, it will be calc based. So we're going to do some of that pre-work today. Today we're doing level 2. Tomorrow we're going to be doing level 3, and you'll have an exit ticket on level 3. Level 2 has to deal with polynomials. Level 3 is where we include those special functions. But we'll go over an example tomorrow. So today we are doing applications of higher order derivatives, level 2. We need some vocabulary and some notation before we actually do our example. We only have one example today and one practice problem. If we have time, we'll take the exit ticket, but otherwise that will be left for tomorrow. Okay, first thing, velocity. Velocity, you have studied in physics. We know that velocity is the speed or rate of an object in a specific direction. We'll talk more about specifics on how to tell the direction it's going when we come back from break, but this week is just an intro to physics or applications. Today and tomorrow will just be physics applications.
So we're not doing the left and right yet?
We will. We will. That's fine. You could have left it in Spanish. In anything we do, we have to have units. So, way back in November, December, when we were doing rate of change problems, we had to use units. For velocity, or for any derivative, first derivative, the units are going to be, not unite, units, are going to be your y units. Why do I keep putting unite? Yeah. Are we united? Y units over x units. Meaning that in the context of the problem, they'll tell you what your y is and they'll tell you what your x is. Okay? So for example, you can write it as a fraction. So let's say it's meters per second. You can put meters per second. You can put m per s. Or you can write it out. Meters per second. Any one of these is fine, but you have to have units in these problems or you will not get your full points. Are we clear? Okay. What'd you say? Next thing we need to talk about is acceleration. Acceleration is, can I go right there? Does everybody have the definition of velocity at least? Can I go there? Nobody's saying anything, so I'm just going to go. Thank you. Acceleration is the rate of change of velocity, which means that acceleration is the derivative of velocity. Acceleration is the derivative of velocity. The units for that are, can you see that color? Okay, thanks. They're going to be the y units over the x units squared. So, meters per second squared. Feet per minute squared. Your denominator will be squared. For acceleration, your denominator will be squared because it is your second derivative. And you'll see what I mean when we get, excuse me, when we get to a little bit more information. Okay. Now let's specifically talk about physics. In physics, we have three different functions. We have the first function, s of t. Okay. S of t will give us the position or the distance traveled of an object. So if I have a function and I put, let's say I want to know where it is after 4 seconds, I substitute in 4, that gives me how far it has traveled or where it is on that line. That is what that means, s of t. That is the position function. Now, here's where calculus and physics come together. The derivative of the position function, that's s of t, is velocity. The derivative of the position function is velocity. This is the instantaneous velocity of the object. So the first derivative is the velocity. The first derivative is velocity. When we are doing these problems, you're going to need correct notation. If I ask you for the velocity function, this is the notation for the velocity function. Questions? I know this is a lot of vocabulary, but you'll understand it hopefully.
What's the name of the second derivative?
What is the name of the second derivative? I'm going to have you guess based on the vocabulary I gave you. Acceleration. Thank you, Joanne. I'm going to, I know you're still writing, some of you are still writing, so I'm just going to move this up. Okay. So, as Walter asked, the second derivative, which is the first derivative of velocity, is acceleration. So this is acceleration. And this would be the notation for acceleration. Oops, am I off screen? I spelled that wrong, but you know what that means, I hope. Acceleration is the instantaneous, oh, I spelled that wrong. Rate of change of velocity. So way back when we did rate of change, we know that the derivatives gave us a rate. No matter how many times we take this derivative, it will always give us some type of rate of change. We will be only going to the second derivative, so that's all we have to worry about. So this is the first derivative of velocity, but the second derivative of the position function, or we really call it displacement. Oops, sorry. When you're done copying that down, take out the example sheet that I gave you. When you're done copying that down, take out the example sheet I gave you. Ready? Are you sure? Thank you, Joel. Okay, so let's look at the first and only example we have. It says the position of a particle is given by this equation, where S is in meters in after t seconds. So before we do anything, the first thing you want to try to do is figure out what your units are, because your units are what matters a lot to get you from that half a point to that full point. Because if you don't include the units, you will not get the full point. So we don't have y and x here. We don't have f of x. What do we think would be x here? Which variable is x? T. Good. So t is going to be my x. Here it's seconds. That means the other thing, s, is in meters, which is y. Are there any questions on that? We're sure. Okay. So now, let's look at the problem. Part A asks me to find the velocity function. Velocity function. So, as I said, the velocity function is the derivative of your displacement function. So here is our function right here. This is our function. By taking the derivative of this will give me my velocity function. So v of t is equal to 3t squared minus 12t plus 9. Are there any questions on where that came from? Now, if you want to write s prime of t, that's perfectly fine. But you need to also have the v of t. If I see just the s of t, you will not get full credit because I'm looking for velocity. S prime of t is not the correct notation for velocity. Are there any questions how I got the derivative?
You don't put that S prime?
You don't have to. No. You don't have to. But if you do so that this way you know that that's the first derivative, I don't care. Okay? Yeah, so this is optional. And this is required. I spelled required wrong. Okay? Questions? All right. Let's look at part B. It asks for the velocity after 2 seconds and after 4 seconds. What does 2 and 4 stand for in this problem? T. Good. How do you know it's T? Because of the units, because of seconds. So this is going to be T, and this is going to be T. So what do you think we need to do in order to solve for this? Substitute. Good. So I'm going to substitute in the 2, and then I'm going to substitute in the 4. You need to write a phrase. Okay? This goes back to what we did a long time ago. So I'm going to substitute in 2. So v of 2 is equal to 3 times t squared. 2 squared. Can you guys see that I'm writing? I'm not off screen, right? So v of 2 is equal to, can somebody put this in their calculator? Give me an answer, por favor. What? -3? Okay. Don't forget your units, meters per second. Do the same for 4. What is it? I think it's 9. Okay. So don't forget to write your little phrase. After 2 seconds, the velocity is -3 meters per second. Again, we'll talk about what the negative means after break. After 4 seconds, the velocity is 9 meters per second. So that's all for part B. What? Yeah.
Dude, we're not supposed to do that yet.
I don't know how you I'm not sure.
What do you mean you're not sure?
What? What'd you say, Walter? Okay, so the 2 and the 4 stand for t, right? So I took the 2 and the 4 and I substituted into this equation. Okay? And I just put it in the calculator. Put it in the calculator. I can actually do it in my head, but you would have to put it in the calculator. Unless you can do the work in your head too.
So even like the 9, that's like you add, okay.
Yep, because it is part of the function.
Yeah, I was thinking about like derivative y.
Oh, no.
Okay.
Okay. What does it mean when the particle is at rest? What's 0? Not time. Not time is seconds.
That means it's not left or right, right?
And so what is it? What part of the equation is it?
The acceleration.
No, we're not on acceleration yet. Nope.
Wait, huh? Is that right?
So when it's at rest,
Are we talking about the force?
yeah, it's 0. What's 0 though?
Oh.
It's not t. She just said that.
Okay.
It's not s. It's v of t. The velocity is 0. The speed is 0. So 0 is equal to 3t squared minus 12t plus 9. Now, if you are a whiz at factoring, great. You can factor and solve for t because we're trying to figure out when it has no speed. We're trying to find the answer to the equation when it has no speed. But I know that some of you are not great at factoring, so we're going to use the calculator. So everybody grab your calculator.
No.
Well, that's on you if you don't want to learn it. Okay, I'm going to be working on 2 calculators, so please pay attention to which calculator you have. So we're trying to find the roots. We're trying to solve this equation. I'm going to be working on 2 calculators at once, so please bear with me. If you don't remember these steps, you can go onto Google Classroom. They'll be posted by 5 p.m. today. Additionally, if you don't have this calculator already on your phone, I will try to post a video on how to use it on the phone, but you can't use your phone in class, so you have to learn how to use it on here, okay? First thing you should do is hit apps. Yes. Hold on, I'll get there in a second. So, you should see one of 2 screens for apps. Hit apps, it's APPS. It's like second column, look, Joanne, sir, apps. Look up on the screen. Look on the screen, sir. You got it? Okay. If you have this screen, you need another calculator. Please give me the calculator because I'm going to have to update it. So, if you have this screen, grab another calculator, like now. Like now. Thanks. Oh, this one just needs batteries? Yeah, it needs batteries.
If it shows up like this, then you're good. But if you only have one, then that means you're in the calculation.
Nope.
I have pictures. You don't. Oh, the second time won't be able to. If there's any tests, please.
Give me a second. There's a bunch of them that. Okay, here we go. All right. Okay, seniors. So now that we're trying to solve for this, we need to go to something to solve it. If you are on this calculator, you go to number 9. You can either hit the number 9 or 9. Same here. Does everybody see one of these 2 screens?
Yeah. Rule number 9?
Yeah. Okay. If you see this screen, hit enter. Now you should all be on the same screen.
How do you know it does that?
Huh?
How do you know it does that?
Hit apps and you'll see a long list or not. Okay. We need to solve this polynomial. So you're going to either hit number 1 or hit enter. You should see these screens. You should see these screens. Everybody see these screens?
Yeah.
No? Okay. Now, we're going to work on this one first. Where it says order, this is going to be your highest degree, meaning your highest exponent. We're going to use this. Our highest exponent is 2, not the coefficient, the exponent.
Yes.
So this is 2.
So,
For this calculator, you're going to have to scroll over and hit enter. Okay? If it is not on 2, you scroll over to the number you want and hit enter. Do you all have it highlighted like mine? Don't worry about the rest. Just worry about the order. Okay? Ready? Okay. Then you're going to hit next. So underneath the next, you're going to hit the graph button. Next. Next. Right there. There you go. You should see these 2 screens. One of these 2 screens. Okay. I'm going to work with this one first because it's a little easier. What you're going to do is you're going to put in the coefficients of your formula. Yeah. What'd you say?
it already has it in.
I know because other students used it.
Oh.
You're gonna put in the coefficients. Are we ready? So, if you have a calculator that already has it, you still need to pay attention so you know how to use this, okay? So you're gonna hit 3, or type in number 3, enter. Because this is a minus sign, you have to hit negative 12. And then 9, okay? So this is what it should look like in your calculator if you have this one. If you have this one, just enter in the coefficients. 3, enter. You will see that it takes me to this plus minus. Because this is a minus sign, hit the minus. Enter. Enter in your coefficients. Okay, so it should look like this now. I know. When you are done entering it in, then you hit the solve button, which is right here. Yep. So these are the times the particle is at rest. These are the times the particle is at rest. So at 1 second and at 3 seconds, the particle is at rest. Okay? Does everybody have these things? Have these 2 screens now? Yeah. You're going to have to practice it, okay? We're going to practice today and tomorrow.
So what's the answer?
I'm going to write it. The particle is at rest at 1 second and 3 seconds. Julian, I don't know if your calculator has a solving function also. You might want to check, okay? Questions?
No questions.
So those 2 numbers are always gonna be the rest?
Yes. You might only have 1 rest, but we'll explain that after break because remember time starts at 0, right? If it's negative, then it's not possible to be at rest because you can't have negative time. But we'll talk more about that after break. All right. Part D. Part D asked me to find the acceleration function. Going back to the notes, the acceleration is the derivative of what?
Velocity.
Velocity. Good. So here is my velocity function. That means my acceleration function is 6t minus 12. Guys, I don't know who's doing it, but can we stop with the noise? Thanks. Are there any questions?
No questions.
Do you need me to zoom in? Yeah? Good?
Yeah.
Okay.
Wait, was there an X?
Was there an x where?
Negative 12.
Yeah, but the derivative of negative 12x is what?
Oh, never mind. I was looking at that.
You're welcome. Okay, questions? All right, now it's asking me for the acceleration after 2 seconds and after 4 seconds. What do you think we're going to do with those 2 and 4?
We're gonna plug it in
Substitute it into what?
to the T
For what?
for T for 6.
For acceleration. Because we have lots of T's. We have a T for velocity, we have a T for position. So it's going to be A of 2 is equal to 6 times 2 minus 12. A of 2 is 0. Meters per second square. A of 4. A of 4. And then you just write your little phrase. After 2 seconds, the acceleration is 0 meters per second squared. after 4 seconds, the acceleration, am I off screen? Is 12 meters per second square. Questions?
What does it mean?
What?
What does it mean?
So many? Okay, ask them. You sure? Okay, when you do the problem and you have questions, let me know. All right, seniors, turn it over to the back. You have one problem that needs to be done by the end of class.